Good morning, everyone.
Hello.
Good morning, Sage. All right, we've got a fair amount to get through today, so maybe we should get this started right away. Not a whole lot going on in pull requests this week. Probably the most interesting one, at least in my opinion, is the RTC work you've been doing, Sage. Do you want to talk about that a little bit?
Yeah, it's run to completion stuff from. I'm actually not sure who the person is. Reviewing, in Blue Store so that it will do as much work as possible, including synchronously writing the transaction into RocksDB in the same thread when appropriate. And that is. It basically made me realize there's a bunch of other stuff that was broken. And so there's another patch that I'm trying to merge first that fixes all that stuff. And then we can go back and clean it up. It's sort of two things though. I mean, it's only useful if you have like an NVRAM type journal, something super fast for the database. Otherwise, it's not actually going to be an improvement. And you can't do it if there's actually any IO. Because you have to go wait for the IO to finish, and we're not doing the IO synchronously, not currently. That would be another whole nother round of changes. But if you have a wall IO, then you could do the database IO synchronously, and then the actual override IO to happen asynchronously. So that would be an option. But in order for that to happen, then the completions need to be able to be called synchronously also, and that sort of means some refactoring of the interface with the OSD, so that in some cases you can call, basically the call site that assumes that it's queuing it asynchronously might actually synchronously complete. And so we need to make sure all those call sites can handle it and the completions can handle it with their locking and so on. So there's some more work to do there, but it pushed us down the road. So we'll see.
I should mention that you're, as you mentioned, Sage, the original author of some of this is Voidbag, whoever that is. I don't actually know his real name, but Voidbag is the original one. I guess was pull request 11966.
Yeah. Yep. Yeah. His name is in the thing somewhere. Takes on Kim something. I don't know. Anyway.
Sorry, my connection just went out there for a brief moment, so I didn't actually hear what he said. But oh, good.
I think that's the only main thing going on there, though. Yep. You go ahead.
Okay. Cool. The only other, I guess there's a couple of things here, but Soneth has been playing around with a couple of different things, and you mentioned this morning in stand-up for Blue Store that sync submit transaction being enabled is maybe hurting us a little bit, so I'm going to try to reproduce that. Igor saw some performance regressions in Blue Store potentially. I did not see what looked like strong evidence of that when I did a bisect recently, but I need to go back and try to reproduce it again just to make sure. And then the only other thing I wanted to talk about with Blue Store this week is that when looking at using column families in RocksDB, we talked a little bit about that last week, but it appeared that there was maybe some evidence that column families were improving performance, and that was actually not the case. the only way at the time to get column families to work was to set the BlueFS allocator to bitmap. And it appears that that is actually what was resulting in a performance increase for small 4K random writes to pre-allocated volumes. And I do actually just briefly here want to show a graph of that. Let's see if I can share quickly here. Let me do that. Entire screen. Oops, not this one. Can you guys see this? So,
yes.
So the gist of it is that when I went back and looked, these are 2-hour tests, so not real long, but also not real short. What I saw basically is, in general, with the bitmap allocator used for BlueFS, we're not quite as spiky. We're more consistent, and the overall performance level is quite a bit higher, probably in the order of about 20 to 25%. We also seem to avoid this large stall that was present with the stupid allocator towards the beginning. So the scale of this is a little bit hard to see. I suspect that some of these dips are actually quite a bit lower. That's kind of the behavior we've seen in the past, where we kind of have these periodic stalls that are fairly short but are associated with RocksDB compaction. But for whatever reason, with the bitmap allocator, things generally appear to be quite a bit better. So anyway, I don't have too much time to go or to talk about this anymore, because actually we've got folks from Nokia that want to present on some BlueStar findings that they have. But we will
so before you go, right, one question here. So you have data for weak column family plus bitmap. So you don't have data for weak column family plus stupid, right?
We do not, because currently it's crashing after 10 minutes.
So how do you know that it's not column family that's been helping?
Because with the master branch that what column family is based on, basically commit 80.
Okay, giving a similar result. Got
yep,
it.
we see almost the same level of performance.
Yeah.
It's very similar.
Got it. Yeah.
Yep. So
I think you're going to find that the benefits from column family deteriorate as the size of the volume increases. So you have a 32 gigabyte image here. You're kind of exaggerating the value. No, it says eight 32 gigabyte images.
Yes.
Right. So it's a 32 gigabyte image, 8 of them.
Yes. So an aggregate of 256 gigabytes.
Okay. So 256 gigabytes. Yeah, which is a pretty small device. I think you're going to find that if as the device size increases, the incremental benefit that column families yields declines. It's going to get swamped by the O-node compaction traffic.
Yeah.
Alan, we're not seeing any benefit from column families here. It's entirely from using the bitmap allocator for BlueFS.
Okay.
Yeah. It's still super surprising to me, because BlueFS doesn't even persist. This is just in-memory tracking of used extents, and it's just very surprising that makes a big difference to me at all. But anyway, I'll reproduce it.
Cool. Yeah. So that's definitely, I would like to see someone else show similar results before trusting this 100%. But it seems to be the case that if that's the only thing I change, and I am seeing different behavior. I should also mention too, before I turn it over to Nokia, that in other tests with like large sequential I/O, the bitmap allocator appears to be doing worse. So it may not be a universal win here. So it's probably worth understanding what the behavior is in each case to try to explain this.
Yeah, I mean, these are the only allocation decisions it affects is where BlueFS is writing its RocksDB metadata, which is a comparatively small amount of data compared to everything else. So I don't know. Yeah. I'm just suspicious. That's all.
Yeah. Could it be possible that it's changing the way RocksDB does its compaction, or the way that it's having some kind of strange effect on its behavior?
It does, but I don't think it's going to change it in a material way on a random write test.
Yeah.
And also you have started seeing benefit from the beginning, right? Compaction effect will become a bit later, probably, right? So it's from the beginning itself, you are seeing like that high number.
Maybe it's just a CPU.
Yeah.
It's not even making that many allocation decisions. Like, it's allocating in 1 meg chunks. I don't know. It's really weird.
It's always possible for something, ridiculous, right?
Yeah, that's probably what's going on.
All right.
I mean, if the bitmap one works, then like whatever, just use it. Okay.
All right, cool. All right, that's all I've got for this week. So I'd like to yield the floor to Ben Niven-Jenkins from Nokia, and they're going to talk a little bit about some Blue Store testing that they've been doing there. Ben, it looks like you're muted. I'm going to try unmuting you here. Nope, can't do it. There's a little icon next to your name, or at least on your little sidebar there, that should let you unmute.
Can also press the space bar.
Ben, it looks like you're still muted. Now you are unmuted, but we are not hearing you. There's also a chat window that you can bring up if just to let us know you're here, if possible. Okay, good deal. Yeah, we can't hear you. Not sure if. Okay, so I guess Ben's going to try to phone in here and see if he can do audio that way. Maybe while we wait for Ben here, is there anything else that folks would like to discuss this week that we haven't touched on?
So before Ben comes up, right? So I have some small data set, like small run. So if you have time, like I can just quickly present and get your valuable feedback on that.
Sure, go for it. I think Ben was going to use up about maybe 30 to 40 minutes, so we probably should cut it off once he gets back. But until then, go ahead.
Can you see this?
Yeah.
Yeah.
Okay, so so this is the way actually I'm trying to simulate the big image preconditioning, how to get rid of that. For example, I have single OSD and I'm trying to put like 1 terabyte image on that and make it into a steady state. So I have to do 4K sequential write, and it will take me like 12 hours, 13 hours. So we discussed with Sage, and we come up with this idea like writing 0-byte object to RocksDB through Bluestar first. That's actually I did. I preloaded with like 22 gig of data with that, but those basically it will be a date metadata. It will never be touched, but it will only fill up the RocksDB. So with that I fill up, and then I created like small image like 100 gig and did a 4K sequential write to precondition and make it that's the image to steady state. And you see the behavior. So for RocksDB tuning work, I did a bit change than yours. That we can discuss later. But yeah, so this is the behavior with 100 gig, and see the CPU percentage here. It's around 80% is used. It's a 1 hour run after fully preconditioned. So this is the stats for like the different DB partition, wall partition, and data partition. Data is actually going on the actual write, and I collected all the stat on that. So you'll see that this blue one, it's the read. That's what is mostly happening. Okay, go to the next slide. So this is the data write. Data write is I write around 110 gig of data. Out of that, you will see that at the same time, the DB write is happening around 66 gig, and the wall write is happening around 72 gig. So the write time is nothing. It's probably 1.31 at this run, right? So the read, that's you'll see that 130 gig of extra read is happening, and that divided by I need to still collect that how many ONode reads are happening. Even though actually I gave a bigger ONode cache size, but still I'm seeing a lot of niches. So that will tell your read-am. So that's actually kind of big. So next, if you see that now same thing, 500 gig image, so you'll see the performance is kind of now up from say 8 to 9K. It came down to this one is now around 4K. So and you see the CPU is also 20% more consumed, even if it's generating less throughput. So it's going to the compaction, I believe. So this is the one for like all the stats for 500 gig. You can see how reads are actually climbing up, and the rest of the data. And similar throughput, you'll see that write-up is now increased, like 1.31 to 2.00 something. But see the read-am, 130 gig to 380 gig. So yeah, that's the summary. Is that I don't think that the way of populating RocksDB and trying to cheat the steady state, it's not working that much because otherwise 100 gig and 500 gig would give the similar write-up and similar performance. So read-am is our problem. So you need to see that.
And this was with the 4K min-alloc size, right?
It's a 4K min-alloc size, yeah. So okay. I'm still collecting the data for others, yeah.
Okay. Yeah, I'd be really curious how that changes, but cool.
Yep, and I'm very curious about the ONode misses and why that's happening. I think we should chase that down next.
Yeah,
I think the high read-am strongly suggests that we're not measuring what we think we're measuring.
For what it's worth, I'm seeing pretty high reads too, so this isn't real surprising.
Yeah, I think I'm wondering if the configuration of rocks is getting to something where we think, and if we're not, as we've noticed before, depending on how you set up the compaction, you can trade off, write-am for read-am, and that's probably not what we want. And so, my observation here is if you're seeing super high read-am here, that's not the model that we would be expecting. So ergo, something's not configured right.
Yeah, I can change that. So for in expense of like stalls. So this is basically a number of level 0 files. Means I configured the stalls and the slowdown based on the number of level 0 writes. So 11.0 files. But if you make it super small, you will probably see you will definitely see less reader, but more frequent stalls and the slowdowns. So
yes. So
yeah.
right. So what you're doing is you're hiding the behavior you're looking at, but you're making something that's intolerable much worse. I mean, if you were laying a latency graph up against this, you'd be seeing your latency going up, I don't know, to seconds maybe. I mean,
Well,
I forget, what was the rate amp you were showing? Was it 5 to 1 or 10 to 1?
Yeah, it's not exactly actually able to meet because we need to measure that how much of node read also going on. So that's what actually Sage was asking, right? So how much, what is the misses is happening? How many misses? So that divided by the read.
Hey guys, let's wrap this up for this week, and we've all got more testing to do in this area anyway. There's definitely lots more work to do. But Ben, I think, is ready to give his presentation. So let's shelve it for now and bring it back up next week. Okay, Ben, are you
Hi, Mark.
here?
Can you hear me?
Yeah.
Absolutely. Yes.
Can you hear me? Oh, good stuff. All right. I'm on with a colleague as well called Mutu, who's just to give a bit of explanation. So yeah, my name's Ben Niven Jenkins, and I'm the chief video architect in Nokia. Mutu works in our development team, and he's done a lot of work on Ceph and BlueStore in particular. So what I'll present is really a few slides just to introduce us and what we do and a couple of our key use cases and how we use Ceph, and then Mutu will cover sort of more details of the testing he's done and the experience he's had. So can everyone see the slides that I've hopefully shared?
Yes.
Yep. Perfect. Okay. So first off, who are we? Nokia's quite a big company, as you're probably aware. And so where I work, where Mutu work, is in the video business unit, which is part of the networks division. And basically the video business unit, as you'd expect, we make products that deliver television and video across the internet and across broadband networks. We got a range of customers, some of which I've included on the slide. Our customer base is primarily like telcos, ISPs, cable operators, although we do have some content providers like HBO and things as customers as well. We have 4 primary products. The first is a content delivery network product that does in-network sort of caching and scaling and distribution delivery of HTTP content. The second product is a cloud DVR that I'll talk a little bit more about because that's the product that we use Ceph in. We have a personalization platform that does and it sort of integrates to enable ad insert into video streams, and a broadcast optimizer that's for older IPTV networks. So what is cloud DVR? It's basically taking the personal video recorder that you have in your home and having that in the sort of quote-unquote cloud, where really it's in the network. So the recordings that you want made are made within your ISP's network, and then they're available to be streamed to you wherever you are, be that on your television in home or on an iPad in your home or on an iPad or a mobile device when you're outside the home. And that's enabled by doing the recording in the network and then streaming from within the network. This is a marketing slide, really. I mean, I won't talk too much about it. I think the point here is that the amount of people that consume non-linear video and time-shifted video is quite large and is continuing to increase, and that drives a demand for our products. I included a little bit here. I won't go into a huge amount of detail, but the video, the way that we typically deliver video and the way video is often delivered online by folks like Netflix and so on is what's called adaptive bitrate video. So the basic essence there is the TV channel or the video on demand asset is encoded into multiple bit rates, and then is segmented into different files, essentially, of it typically ranges between 2 and 10 seconds. So let's call it 2 seconds of video is a separate file. That's available at different bit rates. It's all requested over HTTP, like normal web transactions, and then the client is able to adapt to the underlying network conditions it has, bandwidth essentially that it has, by selecting a different bit rate depending on its circumstances. So, for example, clients will quite often start at a low bit rate, and as their video buffer falls and as they detect they have more bandwidth, they'll request higher bit rates. And then if there's a problem we get in a particular bit rate, they can rate adapt down again, and therefore it's sort of able to trade off absolute quality. So you don't always get the highest quality of delivery, but you get the highest quality that the bandwidth that you have available to you can support, and that can adapt over the time of the video. What that really means is when we're recording this video, then we have multiple bit rates to record, split into segments of a few seconds, so we end up with lots and lots of objects or files in the storage system. Very basic architecture of how the product works. From right to left, we have ingress modules that bring in content that's pre-encoded, that do some processing on that and effectively store that into Ceph, which is our storage layer. We integrate using librados rather than a gateway. The primary reason for that is we want to drive as much performance as we can out of Ceph. And then there's some surrounding components like a database to help us manage some things, some management interfaces, and some egress modules that will take content out of Ceph when it needs to be played out, possibly transform that between different video formats depending on use case, and then delivers it out. In most of our use cases, there's then a CDN, a content distribution network, in front of the cloud DVR, further scaling out the play out of the video. So the CDN will cache video, and if multiple people request it, they get that from the CDN cache rather than going all the way back and hitting Ceph as a read for that. There is one use case where that doesn't apply and the reads come out of Ceph directly, but I'll talk about that in a minute. So then I just have a couple of slides on a couple of key use cases, and I'll hand over to Mutu for the sort of interesting test details. So one use case we have, some people call it a sliding window, some people call like a circular buffer, but essentially what it is we'll permanently record and then make available the last N hours of content. So it depends on the broadcaster, what they offer, but could be between two hours and a week's worth of content. And then while you're watching television, you can press rewind and sort of rewind into the past from a live point and fast forward up to live again, and have that sort of seamless kind of user experience without having to have actually sort of forethought and selected to record something. How that interacts with Ceph, or the storage layer underneath, really is we end up writing a continuous stream of video chunks or files of a few seconds of video in multiple bit rates 24/7. The CDN in front minimizes the read rate that we have to support, but the write rate is sort of determined by the number of channels and the number of bit rates that are available. And if the CDN doesn't have a particular video chunk cached, it goes back to the cloud DVR and ultimately to Ceph to read that out and then cache it. And because it's a circular buffer, we're continuously kind of writing new video in and deleting the old video that's sort of at the end of the buffer at the same time. So we're doing constant sort of writes, reads, and deletes, which then sort of places some high-level requirements on the underlying storage of consistent kind of performance, even in the case of single failures, and obviously a storage technology that's redundancy and fault tolerance. And the reason for the consistency requirement is really we're doing a consistent amount of write all the time. We're supporting a large number of channels. We can only have so much sort of buffering in RAM and things before we need to actually have it in permanent storage and out of RAM. The next use case is similar. It's what we call shared copy. This is where a user's actually explicitly requested a copy of a program, and the normal way that we do that is we make one copy of that TV program that is then shared between all the users that have requested it be recorded. So 1,000 users might ask for a program to be recorded, and we store that once in Ceph. The interaction is similar to the kind of sliding window use case I just talked about. It's a continuous sort of stream of video chunks, but it's not continuous 24/7 in the same way, because obviously popular television is typically focused in a few hours in the evening, and that's what most people record. And then during other parts of the day, people are recording things, but that's not like the peak demand on the system. Also, when people tend to watch video, overlaps with when they tend to record it, so the read and write peaks overlap with each other. But because the content is shared between many users, we can leverage the CDN to cache it and help reduce the read rate. Deletes typically occur when the last user selects to delete a program, or in some cases there's a configured sort of retention period where, like, after 6 months, content is deleted whether the user requested it or not, for example, which drives similar requirements to the previous use case in terms of storage. And then the last one is what we call private copy, which is different to the previous two. Where that is typically used is where a content provider has a demand that our system effectively emulates each user having their own video recorder in their home, which means that we have to make a recording of a program for each user that requests it. So 1,000 users request it, we end up making 1,000 recordings in Ceph. Other than that, the way it works is basically the same as shared copy. There's just more recordings in parallel, and because we're making one recording per user, the other difference is that the content distribution network in front doesn't add value because the content isn't shared between multiple users, and therefore the full kind of read bandwidth is coming out of Ceph essentially. And that places an additional kind of requirement to try and get the cost of the system as low as possible. Typically like a few dollars, maybe $15, $20 per user for a customer, something like that, maybe. And that drives our sort of deployment architecture a little bit in some cases in terms of the nature of the hardware that we're deploying on, and there are some aspects of it that are, I think, different to a typical Ceph deployment. Like, we don't use SSDs and things purely from our customers cannot tolerate that cost. So, Mutu, are you able to take over from here with the testing that you've been doing?
Yes, Ben. Can you able to hear me?
Yeah, I can hear you.
Okay then I'll just continue. So depending on our customer requirements, we have two type of production deployment hardwares. One is the Apollo 4200, which is a medium scale storage system. It has 28 CPU cores running at 2.4 gigahertz, 256 GB RAM, and it has 24 4 terabyte disk. And for the Ceph, we allocate 14 CPU cores and 128 GB RAM. The other hardware is a high storage density. It has 32 cores running at 2.3 gigahertz. Total RAM memory is around 384 gigabytes, and it has 68 disk of 4 terabyte. And then for the Ceph, we allocate 16 cores and 256 GB RAM. Apart from this, we have 3 SGI nodes as our test platform to include the various development builds of the Ceph. It has 20 CPU cores running at 2.5, 256 GB RAM, 40 disk, having 6 terabyte, and this is purely for playing the Ceph tunings. So on the next slide, actually gives the architecture about our product. Each hardware will have 3 softwares, mainly the Ceph, and VXOA is the recording engine, our recording engine, which will be going to be the client for the Ceph. And this VXOA uses Cassandra database to store the video metadata informations. So in terms of the resource allocation, we allocate the socket 0 or the node 0, all the CPUs as well as RAMs to the Ceph, and we allocate the socket 1 or the node 1 CPU and RAM to TAR, VXOA as well as Cassandra. Again, depending on the customer requirements and the storage requirements, we do have 5-node cluster as well as 10-node clusters. So, and in terms of the network architecture, we have provided 20 gigabyte, 20 Gbps bonded interface for the Ceph, public as well as private interfaces. And then we do have additional 220 gig interfaces for the VXOA, one to communicate with the Ceph and one for delivering the video to the end users. Apart from this, we do have 1 gig interfaces to pump the video from the content provider to the our cloud TV solution. Next slide, Ben. In terms of the performance test process, after validating the functional testing, the software comes to the performance team where we install them, we integrate with the other products, and then we do a basic Rados bench for the read and write of various object size. Once we have decided number of read and write performance, then what we do is we do benchmark the number of channels which can be created for on a particular platform. Depending on the bit rates, it just varies. So we just take that number, and then on stability, we just include the next set of load onto it, which is going to be the recordings. So this recordings basically involves read and write operations, which will be added to the existing ingress or the channel creations, which is an intense write and the delete operations. So above that, the last part will be we will be adding the playback sessions to it, which is comprising of the read operation to the Ceph disk, and we just benchmark based on the customer profiles, and once we reach the customer requirements, we just do a soak test, which will run for 2 hours or 3 hours. And if you are not meeting the customer requirements, and then we do some fine tunings on the Ceph, and then the process continues from Rados bench to benchmarking the various profiles. And then once the soak test is over, we just deliver to the deployment team where they deliver to the customer premises for the next set of customer focused tests, and then final delivery to the customers. We do work in Ceph for almost 2 years, starting from Firefly to Kraken. We do have seen a lot of integration issues with the Ceph file store, and a lot of challenges we have seen, which we will see in the coming slides. During the month of May and June, I think we have seen some presentations related to Blue Store by Sagewell, and then we thought of validating it because we have seen a lot of issues with write and the delete with respect to the file store. So this was the first step which we did was we have integrated the Blue Store onto our test SGI platform, which is having 3 nodes. We used erasure coding 2+1, and then we did with the dual file store. What we did was we did a Rados test, writing 2 MB object continuously from 0 storage to almost 24 hours to fill, crossing the 50% of storage utilization. So what we noticed was the initial stage with the file store, the performance was around 17 Gbps. Then it got drastically dropped, and then when the storage was around 50%, we saw it drop to 12 Gbps. So we did the same test for the Blue Store. Initially itself, it gave a tremendous performance improvement, like 28 Gbps. And then the test was running for 24 hours. Still, the storage was filling, crossing the 50%. And interestingly, the performance stayed constant with the same 28 Gbps. So this was the first test we did with Blue Store, and we just reported this to our management to continue some investment on this Blue Store. So in terms of numbers, based on this, what we have projected was in the initial stage of the storage, we saw 60% more throughput when compared to the file store. And when the storage is at utilization is very high, close to 50%, we saw almost 130% of storage utilization. And this, in this system, we could have reached better, but the disk IOPS was the bottleneck, whereas we had plenty of CPU resources. So then we tried to integrate the Blue Store with our application, and then what we saw was after 6 hours, the Ceph getting crashed, and every time we have to rebuild the cluster again and again due to some OSD crash issues. And then we reached the Ceph community team, and they were pointing that in the coming releases, this crash would be solved. So what we did was we tried to clone the Ceph master repository, and once in 2 weeks we tried to rebuild the RPMs and then validated the stability of the system to ensure that the issue was fixed. Luckily, just before the release of Kraken development release, 1 week before, we got a development build where it got solved, and then we started moving this Blue Store to our production hardware. So those are the results which we can see in the next slides. Next slide, Ben. So this is the performance on our high storage architecture, 4510 5-node architecture. So here you can see that the object size ranges from 256 KB to 4 MB. And here what we want to highlight is the Jewel file store and the Kraken Blue Store on the release 11.0.2, almost pretty much same performance. There is no much difference. But what we saw was, in terms of file store, when the storage utilization is high, the performance degrades. But whereas here, the performance remains almost same. Another point we want to highlight here is the Apollo 4510 is a high storage architecture where we have huge number of disks. So in terms of the cluster, we have 68 into 5 times disk. But we have only a high number of IOPS on the disk storage, but we could not able to achieve more write throughput or read throughput, where we see a lot of issues on the CPU becomes a bottleneck here. Next slide. On our medium storage architecture, we did the same test. So here, the first column gives the performance numbers of the write for on the Jewel file store. And interestingly, if you see the second column on the Jewel Blue Store, you can see for the low object files 256 KB, it is almost doubled the performance of the file store. And if you see the overall on the Jewel Blue Store, from top to bottom, the performance is almost consistent. Whereas if you see the Kraken Blue Store, what we saw was there was a decrease in the significant amount of performance, write performance. And if you see, compare the Jewel file store and the Kraken Blue Store, it will be more or less same. But the Jewel Blue Store was very odd and high performance. Then we did some analysis and then found that the only difference which happened in the Kraken Blue Store was the message type being changed to async from simple.
That's
this,
a very easy thing to test. You can just set ms type equals simple and see if that makes it.
Yeah. In the next slide we did also
Okay.
that also.
Okay.
So on the file store, the same error like when the disk utilization is high, we have seen performance drop. So these are the 2 points which we want to highlight here. Next slide, Ben. Yeah. So here you can see the complete thing. Like the first column has the dual file store, dual blue store, track and blue store with async, and track and blue store with simple. So nothing can be matched with this Ceph blue store performance. So it was looking very odd for us, and it has the highest performance I've ever seen in Ceph throughout our testing. And with the Kraken async, yes, it was matching the initial performance level of the file store, but only thing is it is consistent throughout the thing. So as you said, we modified the message type to simple, and what we see is apart from 256 KB and 512 KB, the rest of the things you can see there is a quite performance improvement.
Were you just sorry to interrupt quick? Were you CPU limited in these tests?
Pardon?
Were you CPU limited in these tests?
No, this platform we have limited with the IOPS.
Okay.
This is super surprising. Have we seen this kind of difference with async messenger? There was a small regression on like random reads I thought you saw, Mark, but nothing like this. This is like 30%, 40% or something.
Yeah, but it looks like it doesn't really matter with the async messenger, right? Because in the last two columns here, both the async messenger and the simple messenger are doing poorly.
No, simple comes back up. Simple is doing the same as.
Oh, only for the 4 megabyte though. 4 megabyte and 2 megabyte. For 1 megabyte and smaller, it's still worse than Joule was. But that's interesting. That's why I was wondering about CPU, because for erasure coding with like small file sizes, I would expect that the CPU usage would be dominant in these tests. And that might indicate that like our CRC, the CRC stuff that we added since like Joule might be impacting it.
Okay. Yeah, but this system has a high CPU resource.
Okay.
CPU was not any issue here.
Okay.
So these are the points which we want to summarize on the Radar's test results on the different platforms which we have. So in summary, we see a better performance in message time simple, and in fact on the 12 blue store it was very high.
Mm-hmm.
That was the point which we want to take it. Next slide, Ben.
Oh, you know what I bet it is? Hold on. I bet it is the CRCs because by default, Rados is going to do CRCs over every 4K chunk. And so even though you're doing large writes, it's still a lot of more metadata, which means that there's a lot more stuff in RxDB, which means that compaction is going to start to be painful. I forgot this is a spinning disk. So if you're using librados directly, there's a hint that you can set that says that basically that you're reading and writing the object sequentially. And if you set that, it's going to use a much bigger block chunk size when it does the CRCs, which is going to collapse the metadata down back to what it was with Joule. And you'll probably see that number come back up. So it's you're using librados directly, right?
Yes.
All right, let me find it. Method files. Using the C API or the C++ API?
No, this is a simple Rados test.
This is the Rados bench test.
Oh,
yeah.
I see. Oh, I
Rados
see.
bench
Okay.
test.
So we should make the Rados bench test set those flags. That'll go fast.
That depends on whether it's supposed to be realistic or,
yeah.
Which data flag?
Well, I mean, if you're doing 4 meg writes, then I don't know. Right, exactly. Okay. But for your actual application, well, yeah, we'll fix the benchmark definitely, and then your actual application, though, I mean, the streaming application is always reading these objects in their entirety, right?
Yeah.
Yes, yeah, we always write the objects and read them.
Okay, so I'll post the link to this. There's the op advise flags, and just look for those flags in the Librettos header file. And if you pass the sequential one, then it'll know that you're going to read and write it sequentially. Actually, no, it's not that. It's
okay, thanks. Brilliant.
These ones. These are the ones. So you'll want to set, you can set like immutable, you can set append only, you can set sequential read, and you can set, yeah, append only, right? Anyway, if you set those, then it'll have nice big chunk sizes, and the metadata will be much smaller.
Okay.
Cool. Thank you. Do you want to carry on, Mutu?
Yeah. Next slide, Ben. In terms of our application, we do have a lot of customer focus use cases. Not able to share them, but what we can share is on the real improvement numbers. So in terms of the shared copy feature, where it comprises of the channels, new recordings, recording deletions, and the playback mix load, we have seen significantly 3 times performance boost when compared to the file store. So these tests, we continued with the Kraken Blue Store async type. So we have continued all the tests with the default one. So we haven't modified the message type to simple for on our applications. So on the private copy recordings, which is having intense write operations as well as playback, we have seen 2 times performance boost. And the delete we have been concern for us because our application does extensive delete operations, and we have seen very less performance in delete when compared to the write or the delete read. So with Blue Store, what we have seen is there is a correction. So it is 900 GB. So to delete 100 recordings, the total size was 900 GB. Which is comprising of 540K files. It took around 22 minutes, which is very good when compared to the file store, which is having a very number in terms of hours. But what we saw was we do have a lot of small files, which is creating the issue when compared to the larger files. So this is the point which we want to take it. Next slide, Ben. So these are the summary of the challenges and the issues we face on the file store. The first one foremost is the performance degradation in the file store when the storage increases. So this we have seen many times. And the next one is when we have deep scrubbing, we saw a significant performance drop. So we suggested to simply turn it off on all our platforms. But really we don't know what is the added advantage of having deep scrubbing, and does it really helps in making the stability of the cluster. So maybe if you guys can suggest us, it would be helpful in this area. The next issue which we faced is on the delete. So like I said before, our application is an extensive delete operation. So when our application starts a large volume of delete operations, most of the time with the file store, the cluster stability collapses and it reduces the performance a lot. And another area where we see performance degrade is in the recovery, but that is also fine. And we try to calculate the recovery time because it is being requested by several customers. But we tried several iterations, but until now we couldn't be able to identify our metrics, what will be the recovery time when we have X number of storage. So this is also our concern, one of the concern where we could not able to share this report to the customers. We also face some XFS corrupt issues. And when we have this issue, we could not able to see them on the Ceph logs. And when this issue occurs, suddenly the IOPS on the uh, node increases and finally collapses the whole cluster performance. So only with the deep scrubbing initiated manually, we could able to find these kind of errors, and then we could able to remove the OSD out of the cluster, reformat with the XFS, and then reinsert it into the cluster. Then only it got solved. We do so. The next one, we do have a lot of hardware failures on the disk, both in the lab as well as productions. So we also consulting the HP about this issue. Another major concern we have is on the scalability, because when the customer needs high storage, we increase the 5-node default 5-node cluster to a 10-node cluster. Only thing what we see is on the storage improvement, but we haven't seen any significant improvement on the write, read, or delete performance. So the performance of the write and read and the delete stays. Only advantage what we are getting is on the storage and the IOPS. And of course, if you see the two platforms, the high storage density or the medium density storage, in terms of the disk storage, it has high, but the performance wise, we normally get more or less same. Cost wise, it is very high, the 4510. Next slide, Ben. So in terms of erasure coding, what we see, like it has a high storage efficiency compared to replica 3, but due to the cost of the additional IOPS, we see a performance, and especially on the resiliency, which we'll see in the next slides, we had a lot of issues with the erasure coding. And sometimes when a OSD is down, unless it comes out of the cluster, the recovery doesn't start and affects our read and write operations. So these are some of the major concerns in erasure coding, and sometimes the cluster halts, and we could not able to do any of the read write operations until all the 5 nodes are up and running. Next slide. Now, we also want to share the resiliency use cases. So what we do is we do only the basic resiliency on the Ceph cluster, like MON failures, Ceph public interface down, Ceph private interface down, disk failure, reinsert during what are the observations on the recovery, node down, and then when the node comes up again, what are the issues. So if you see on the replica, we haven't seen much of the issues, and we have seen some minor issues, like sometimes 5 to 10 minutes the cluster is down, where we are not able to do read and write operations. But other than that, the recovery part is happening good, and when a disk is inserted, it just fills the disk automatically. When the disk is failure, the rebalancing is happening. All these things are happening perfectly. Only concern is on the replication is what we tried to calculate was when the storage is around 23%, it takes around 9 hours to restore or recover the system. So this is the only concern in terms of the replica. Next slide, Ben. So if you see the erasure coding 4+1 on a 5-node Apollo 4200, the case is completely reversed. So except the MON failure use case, where we don't see any read or write impacts. But if you see on the other use cases, we see quite a lot of read and writes, and most of the time we see the recovery doesn't start at all, and then it just freezes until all the 5 nodes comes in. So if you take any Ceph public interface down, Ceph private interface down, everywhere we have the internal Ceph bugs, which our team is handling. And only good thing is the disk failure. Sometimes we see.
Wait a minute. Hang on.
Yes.
If you haven't marked the OSD out, it's not supposed to recover. Right?
Yeah, but sometimes it doesn't.
Yeah, it's not supposed to. If the OSD that died is still marked in, it's supposed to wait to do recovery. Marking it out is how you tell the cluster to go ahead and recover.
Okay.
There's a configurable in the monitor that controls how long the monitors wait to mark it out. But the assumption is that you don't want to do recovery if you just rebooted the node.
Yeah, I
So
think the
there's a
default
5
value
minute
is
timeout.
600 seconds. Yeah, the default value is 600
or 10
seconds.
minutes,
Right?
yeah, it's quite a while. So if you don't want that behavior, then you can change it. But it's not supposed to recover in that case.
Okay. Yeah, then I'll think we'll give this feedback to our Ceph development team and then redo the test. So these are the current issues with respect to the resiliency and the erasure coding 4+1. Next slide, Ben. So what are plans for the future related to the Blue Store? So with Blue Store, we are gaining confidence in terms of performance as well as meeting the customer requirements. And like how we like to continue validating the upcoming Kraken release and the development releases of Luminous in search of the improvements related to the performance and stability. So as we said, resiliency is another key area where we are focusing a lot of blocking issues. So we will be trying to get out of it by adding some more tunings to it. And another issue seen in the current Kraken Blue Store is when the object size, when we write the big objects which are greater than 10 megabyte, we see memory leak or RAM outage on the system, both using the Redis test as well as with our applications. So we are still investigating on this issue, but we could able to consistently reproduce this.
Do you remember what version of Blue Store or of Ceph you were using when you saw the memory leaks with, or high memory usage at least with Blue Store?
It's 11.0.2 development Kraken release.
Okay, I don't know when that was. There was a period where we had really high memory usage in Blue Store.
Yes.
Due to the amount of cached O nodes, that hopefully that should no longer be an issue in master.
Yes. Yes, that is all for the lower objects, but for higher objects, still that issue is there.
Okay, good to know. Yeah, I'd be interested in if we can replicate that.
We also encountered that issue on some of the development releases, and then it was solved only for the lower objects, like up to 6 megabytes or something. But when we are writing for the bigger objects, we still see the same issue.
Okay. Does that happen right away? Is it pretty easy to reproduce, or does it take a little while?
Yeah, with Redis test itself, we can easily reproduce it.
Okay, cool. Thank you.
And the last point is we want Blue Store in the Luminous version as an official backend. So next slide, Ben. So these are the summary of our key findings. Blue Store, yes, we are seeing a very better performance in terms of our application. We see close to 2 or 3 times performance improvement, and then we have seen some stability also on the Blue Store. And then this point also we have covered, like with the default sync, we are getting less performance when compared to simple, where we also like to see what are the advantages of having async when compared to the simple. And then delete is always there as our concern, because our application is more delete oriented. And for the Blue Store, this point also we have seen several times, like when the disk is filled, the performance degrades, and our high storage platform could not able to get high write throughput, even though we have a high number of disks. So here the CPU or the limiting factor is the CPU. So these are the key findings from our side. So back to Ben.
Thanks, Mutu. So I mean that's all we had in terms of sort of a presentation. I guess like one question I have is this sort of information useful to you guys? Would it be useful for us to continue providing this information in some form? Is there some way that we can work to sort of help you guys with Blue Store development with our testing, or like are there obvious ways, I guess, short of contributing code, which is a separate thing that I'm working towards, where we can kind of help Blue Store and get it kind of great and stable and ready for production in Luminous?
Yes. So you probably know this from all the testing you've been doing, but it's still, Blue Store is changing, fairly rapidly, and even sometimes it's not necessarily a major code change that will make a big performance difference, but we're still pretty actively working on trying to understand several different aspects of Blue Store performance, one of which is RocksDB compaction behavior and how much data is ending up, metadata is ending up in RocksDB and how that's dealt with. But one thing that we haven't had a lot of coverage on is Blue Store with erasure coding, and it was very interesting to see test results there. So that was good. Just in general, keep doing what you're doing. If you can get us Valgrind runs with the memory leak for the 10 megabyte objects, that would be fantastic. But that's sometimes a little tough to do if you're not familiar with Valgrind. So I can definitely help you out there. Yeah, this is fantastic. Thank you very much.
Pleasure. Brilliant. Okay, so Mark, I'm best just working with you on, and I can feed it back into our engineering team about what you need for the memory leak thing. I guess if we find other things in testing, then you guys don't have a problem with us just sort of maybe bringing it up on the list or something first to check that it's not already a known issue, and then raising bugs against you and all that. It's open to that. I guess I'm conscious that I'm not that familiar with sort of open source development, and I don't know what the etiquette is in terms of like raising bugs versus contributing code versus testing versus whatever.
Any and all would be happily accepted. If you want to, we do have a daily Blue Store stand-up meeting. It's about 15 minutes long, so it's real short, where kind of all the active people that are working on Blue Store get together and just kind of discuss what they've been doing. Feel free to join it every day if you want, or if you would prefer to just join it when you have something interesting to bring up, that would be fine too. And also the mailing list is perfectly acceptable, or bug reports. So there's many different ways you can contribute.
Okay, perfect. Yeah. So I mean, I think we'll obviously carry on testing. I'm keen that we feed back to you guys what we find, where we can share things, and yeah, like Mutu said in the presentation, we're very keen to see Blue Store be production ready as soon as possible. And if there's things that we can do to help, or while you're developing, if you think of our application or our setup and think that there might be some testing that we could help you with, then let us know, and we'll see what we can do.
One thing that can be helpful if you can do it, I don't know how difficult it would be in your setup, but if you do see a big discrepancy in performance between releases, like in Joule versus Kraken, any data that you can provide on what was going on the disks, so IOStat or CollectL with using the disk module, anything like that would be useful. And then also an OSD log would potentially help us, because RocksDB will give you compaction stats periodically and some other information in there, which can maybe tell us something about differences between the releases. So anything like that you can provide would probably be helpful.
Okay, sure. I mean, I don't know what we collect as a matter of course today, but certainly we can. I mean, if there's gaps, we can get that data, or look at changing what we need to do to gather it. Sure.
Okay, fantastic. Well, we're a little over our time limit here, but did anyone have any questions for our friends at Nokia here before we wrap things up?
Hi, Mark. I've just got a couple of quick questions and observations.
Go ahead.
So the first thing on deletions, that's something I sort of struggle with. And what I see is when you have a large number of objects being deleted, either through maybe like removing a snapshot or running fstrim or something, it seems the queue on the OSD basically gets overloaded with delete operations. And it sounds like they suffer from similar things, that OSDs start dropping and generally the whole cluster sort of either completely falls over or really slows down. I was wondering if maybe, like there's priority options for sort of scrubbing and recovery, if maybe delete operations could also have a priority set.
Unfortunately, it looks like Sam left, and he'd probably be the one that would have the most insight into that. Want to maybe bring it up on the mailing list as a separate question?
Yeah, sure. It just sort of came to me while I was watching that presentation, so I'll send a mail. And the only other thing I saw was when you were using erasure coding, and you were saying that all I/O was sort of freezing when you lost a disk or a node. I saw you're only using like one erasure chunk for the data, and I'm wondering if you're getting hit by some sort of like min size thing, which is stopping I/O until that sort of has recovered itself. Like we're using 4.1 instead of maybe like a 4.2.
Yeah, the basic requirement we have is to have 80% storage efficiency, and that was the reason why we have chosen 4+1. So, and we normally share this information to the customer also, like probably one disk on a node can go down, or the complete node can go down, where the performance doesn't affect.
You might see.
Sure, Mutu, but I think the suggestion is if we change the setup to have, say, 2 parity chunks instead of 1 or something, and we notice that issue goes away, then that helps indicate what the source of it might be, right? And then we can look at that in a bit more depth.
Yeah, it was just a hunch, and it might be that instead of 4+1, you end up with, I don't know, like 6+2 or something, which still gets you near that 80% of efficiency, but you've still ended up 2 parity.
Yeah, okay. I mean, that's something we can certainly look at and see if it makes a difference, right? It's quite a straightforward thing to try and see, I think, right, me too.
Yes.
It will probably be slower than 4+1, like an 8+2 instead of 4+1, but it'd probably be worth trying.
Cool. Thank you for the suggestion. We'll try that.
That's all right. And the only other thing, because I've been looking again at the same thing this week, is with your current file store, is have you played around with the VFS cache pressure? Because what I found is that if you've got sort of like an OpenStack or some sort of VM environment where you tend to have a lot of hot or a certain amount of hot data, it doesn't have that much impact. But for what we're doing on my cluster, we've got data that might not be accessed for 24 hours, and then it's very intensely accessed. And if the inodes aren't in the in the cache, you get massive increases in both write and read latency as it tries to sort of read the inodes as well as the data. So I don't know, depending on what you're doing, if that might be hitting you as well. as a file
We
store?
also, yeah, we also tried this option to reduce the cache pressure from default 100 to 10. Our Ceph development team did the test, and they came with the conclusion that there is not much improvement after changing reducing the cache pressure
Okay.
to lesser value.
So one thing related to the cache pressure is that we used to do that, like if you make the VFS cache pressure to 0,
Okay.
it will pin that inode and everything. So it will never be released from the memory. So the drawback for it, so that we are actually doing for all of our block testing, but and the replicated testing, and it's giving us the good performance related to the others. But the problem with erasure coded, it's actually hit back to us. The reason is that it has so many small files for the EC. If you are, especially if you are using like 6+2 and all, right, you have 8 of these small files will be there, and because of that, inode is growing, and the amount of memory is pinned in the XFS, which is not released unless you unmount the XFS memory. So unmount the XFS volume basically. So that actually hitting back to us. So be careful with EC on that case.
Okay. Thank you, Somnath.
All right. Well, unless anyone else has any last minute things, everyone have a great weekend and happy Thanksgiving.
Thank you, everyone.
Excellent.
Happy Thanksgiving. Bye.
All right.
Thank you. Bye.
Bye, everyone. Thanks.